Hello, ladies and gentlemen, this is Mrs. Gallagher, and today's learning goal is how to calculate rate of change. So a rate of change is the ratio that compares the amount of change in a dependent variable. Remember, your dependent variable is your y values, and your y values are also known as the output and the range, to the amount of change in the independent variable. And remember, your independent variable is your x values. And your x values is your input and also known as your domain. So this means the rate of change is equal to the change of dependent variables. So it's your change of dependent variables over your change in independent variables. So it's your change in dependent variables over your change in independent variables. And what exactly does that mean? That means your change in y over your change in x. So your rate of change is your change in dependent variables, which is also known as your change in your y, over your change in independent variables, which is your change in x. Now, what is this also known as when we have the change in y over your change in x? That's also known as your slope. Therefore, the constant rate of change of a line is also called the slope of a line. We will find the rate of change by using the slope formula. And remember, your slope formula is m is equal to slope equals y2 minus y1 over x2 minus x1, which is known as your change in y over your change in x. So rate of change is another way to find the slope. Let's do an example together. So let's look at example 1. It states, the table shows the average temperature in Fahrenheit for 5 months in a certain city. Find the rate of change for each time period. During which time period did the temperature increase at the fastest rate? So there's 2 steps to this problem. Step 1, you want to identify the dependent and independent variables. Okay, so your dependent variable is your temperature. Therefore, that is our y value. So your dependent is your temperature, and that's your y. It's dependent because our month is independent. Whatever month it is going to affect our temperature. Therefore, that's our x value. So your month is your x value and your temperature is your y. Again, the month is independent because whatever month it is going to affect our temperature. The temperature depends on the month. So now let's go to step 2. It says find the rates of change using the slope formula. And if you notice here, it says identify your coordinates. So in number 1, it says 2 to 3. So we want to know the change, the rate of change from month 2 to month 3. So you notice from month 2 to 3, it goes from 56 to 56. And you want to identify your rate of change. Identify your coordinates. Now, our coordinates, notice this says x and this says y. So we're going to write it down as our coordinates, 2 and 56. So our first coordinate is 2 and 56. And then our second coordinate is going to be 3 and 56. Okay, this is your x value, and that's your y value, because that's our input and our output. That's our independent and dependent variables. This is also your x value, and that is your y value. So now we're going to use the slope formula. You want to first label our coordinates, x1, y1, x2, y2. And our formula is your slope, your rate of change, is equal to y2 minus y1 over x2 minus x1. So our y2 is 56 minus our y1 is 56 over our x2 is 3 minus our x1 is 2. Your next step, 56 minus 56 is 0. 3 minus 2 is 1. And 0 divided by any number is 0. Therefore, the rate of change is 0 degrees a month. And that is our rate of change from month 2 to 3. Now let's look at the second one. It says 3 to 5. So we want to find our rate of change from 3 to 5. So let's look back at our chart, and we have 3 to 5. We want to find the rate of change at 3 to 5. Remember, you want to identify your coordinates. So this is your x and y, and this is your x and y. So we'll label it again, x and y, x and y. And we're going to write our coordinates down. 3 and 56, and then 5 and 63. And you're going to use your slope formula. And we want to label your coordinates. This is x1, y1, x2, y2. So your y2 is 63, minus your y1 is 56, over your x2 is 5, minus your x1 is 3. So now you have 63 minus 56 is 7, and 5 minus 3 is 2. Now in rate of change, you want to divide here. So you'll say 7 divided by 2. 7 divided by 2 is going to give us 3.5. So therefore, it's 3.5 degrees a month. Okay, we want to find our last rate of change, which is 5 to 7, because in the problem it's asking us during which time period did the temperature increase at the fastest rate. Now we found 2 to 3, we found 3 to 5, and now we have to find 5 to 7. So our first step is to identify our coordinates. So we have 5 to 7, and again, here's our x and our y. X and y. So let's write our coordinates down. It's 5 and 63 is our first coordinate, and 7 and 71 is our second coordinate. So 5 and 63 and 7 and 71. Next, you want to label your coordinates. Always label x1, y1, x2, y2. So now I want to use our slope formula. M equals y2 minus y1 over x2 minus x1. So our y2 is 71 minus our y1 is 63. Our x2 is 7 minus our x1 is 5. So 71 minus 63 gives us 8. And then 7 minus 5 is 2. Remember, we want to divide here. So 8 divided by 2 is 4. So it's 4 degrees per month. And that is your rate of change from month 5 to 7. So again, the question is asking you, during which time period did the temperature increase at the fastest rate? So what is our highest number here? Well, from 2 to 3, we have 0 degrees a month. From 3 to 5, we have 3.5 degrees a month. And then from 5 to 7, we have 4 degrees a month. Therefore, our greatest temperature increase is from month 5 to 7. And that is your final answer. Our greatest temperature increase is from month 5 to 7. Okay, so now I just found a rate of change using a table. Let's now look at a graph. Okay, so let's look at example 2. We're given a graph in this problem. We want to find the rate of change. The question states, the drama department recorded how long the annual school play lasted each year. According to the graph, what was the rate of change between 2003 and 2007. They want to know how many minutes per year. So let's first label our graph. Remember, our horizontal axis is our x, and our vertical is our y. And it states here, here's our year, here's our length in minutes, and they want to know the length of the annual school play. And they want to know from between 2003 to 2007. So let's identify those coordinates. Our first coordinate, we have 2003 here, and we're going to go right up. So our first coordinate is right here. And your x would be 2003. And your y is 71. And then 2007 is right here. We're going to go up. And that's your second coordinate. So our second coordinate is 2007. And it's going to be 67 minutes. Again, we're going to use our formula, our slope formula, our rate of change, which is y2 minus y1 over x2 minus x1. All right, label your coordinates. This is our first order pair, so x1 and y1. This is our second order pair, x2 and y2. So now we're going to replace it. Our y2 is equal to 67 minus our y1 is equal to 71 over our x2 is equal to 2007 minus our x1 is 2003. All right, so we want to subtract across. 67 minus 71 gives us a -4 over 2007 minus 2003 gives us a +4. And we can simplify that. -4 divided by 4 gives us a -1. Therefore, the rate of change of the length of the annual school play went down by 1 minute per year. And that is your answer. Therefore, the rate of change between the years of 2003 to 2007 was the assembly decreased by 1 minute between those years. So now after reviewing how to find the rate of change, given a table and a graph, I would like you to complete the You Try section. Please complete number 1 of the You Try section and complete A, B, and C. Then complete number 2. And we will discuss our answers in class. Thank you.